Okay. So in our last class, we discussed about two insect pheromones, more particularly grandisol and brevicomin. Let's give an entry. Okay. So grandisol will have this particular cyclobutane derivative, and brevicomin. It is more particularly you need to remember that the brevicomin, it's a pheromone isolated from Dendriotis brevicominis. It's a scientific name or a species name. And today, what I'm taking, uh, multistriatin. Okay, multistriatin. This is the one. So then, what is the difference between the brevicomin and multistriatin? So only the difference is in one methyl group. So in multistriatin, one methyl group will be more compared to the brevicomin, and the species family is same, but species are different. Okay, and this multistriatin, it is isolated from Coletus multistriatus. It's a species name. So that means you need to remember that brevicomin as well as multistriatin compounds are isolated from the same family but different species. So that's what you need to remember. And brevicomin will have one carbon less compared to the multistriatin. So that is the difference. So with this, I will go to the synthesis, the method one, and it's also called as convergent synthesis of this is a levorotatory multistriatin. And here, how this is obtained, I think you know that this a compound. What is the name of this compound? It's a 5 carbon containing ketone. This 5 carbon containing ketone will have a alpha carbon. Alpha carbon will have a alpha proton. This proton in presence of base. Here, what is the base? The base is a secondary amine. So what it will do? It will capture this proton. Once there is a capture, there will be a formation of anion. So that anion attack aldehyde and converted into CH2OH. Uh, and afterwards, when CH2OH is treated with potassium dichromate, so potassium dichromate is a base. So what it will do, there will be a dehydration. So once the dehydration occurs, the product obtained is a double bond, an alkene. And what is the of course this compound is called alpha beta unsaturated ketone, right? Okay, so this is alpha beta unsaturated ketone. How that means you are converting a carbonyl compound into alpha beta unsaturated ketone. So just by reacting the a carbonyl compound with formaldehyde and NN dimethyl amine, right? So that means from here to here, it's a conversion of a carbonyl compound to alpha beta unsaturated ketone. And how it is converting this proton is alpha proton. This was captured by a base called a secondary amine, and there will be anion formation that will attack this carbonyl carbon, convert CHO into CH2OH, Then after the CH2OH is obtained, so when it is treated with the base called potassium carbonate, there will be a dehydration, removal of water, converting here double bond. So that is the double bond. So this is nothing but an insertion of CH2 to this carbon. So now it is converting a carbonyl compound into alpha beta unsaturated carbonyl compound. This alpha beta unsaturated carbonyl compound, it is treated with what is called as dienophile. I think you are aware about dienophile and diene. So what is happening here? It's a pericyclic reaction, 4 plus 2 cyclo addition. How it is happening? The lone pair present in the oxygen can react with this carbon. So when there is a new bond formation between this oxygen and this carbonyl carbon, there will be a new bond formation between this carbon and this carbon. And similarly, there will be a new bond formation between this carbon and this carbon. And this bonded pair is moving over here. Okay. Uh, right. So then this multistriatin is obtained. So what you can do, you can try to write the mechanism for the conversion of uh, a, a 4 plus 2 addition kind to a multistriatin. So that you will have a clear idea. Here I'm reduced 2-3 steps uh, mechanism in a single step. So what here you need to remember, there will be a new bond formation between this oxygen and this carbonyl carbon. There will be a new bond formation between this oxygen and this sp2 carbon atom, and there will be a new bond formation between this carbon and this carbon, and this bond pair is coming over here. So that's what you need to remember. So this is about what is called as multistriatin, how it is obtained. So this is the first method of synthesis of multistriatin. So now I will go to the next one. It's called stereoselective synthesis of multistriatin. So I think you are aware about this moiety. What is the name of this compound? Uh, Maybe we can start with this. 1, 2, 3, 4, 5, 6. Uh, uh, it's a 6. Maybe what you can do. So you can start with this carbon because this is a hydroxy. It's a you cannot start with this on the oxygen. You can start with this. So that means it's a 4 carbon containing, more particularly double bond and dihydroxy butene. You can say that. But how this particular compound can be synthesized? So look here. Here I have given a reaction. So it is nothing but a 4 plus 2 reaction. Uh, of course, it also involves reduction by using Lindblad catalyst. So initially there will be a what is that base can obstruct this proton, and there will be a new bond formation between this carbon and this carbonyl carbon. So that is how a bond is obtained. Propenyl group. This is acetylene group. No, acetylene group will form a bond with this carbon. Aldehyde is converted into alcohol, and then similarly one more equivalent of base can obstruct this proton, and that will react with another molecule of aldehyde converted into CH2OH like this, but there will be a triple bond. That triple bond is reduced by a Lindblad catalyst, that is called palladium barium sulfate in presence of quinoline. Quinoline is the catalyst poison. So there it will selectively reduce a triple bond into a double bond. So this is about the how the butene dihydroxy butene is obtained. So now let's so this is I explained about how this butene is obtained. So now this dihydroxybutene, when it is treated with acetone, so what is happening here? You can observe that there is a 2 hydroxy group. That means uh, this will act as a alcohol, and you know that acetone will have a ketonic functional group. This step is nothing but a protection of these 2 hydroxy group. How it is protected? By converting into a ketal. So that means a dihydroxy alcohol is converted into ketal. So now this ketal, when it is treated with MCPBA, MCPBA means metachloroperbenzoic acid. Metachloroperbenzoic acid means it's an oxidizing agent. It will convert a double bond, okay, or alkene into epoxide. This is nothing but a epoxidation. Then after the epoxidation, it was treated with a Gilman reagent. So what is Gilman reagent? Dimethyl lithium cuprate is called Gilman reagent. So what is happening here? There will be a new bond formation between this methyl group and this carbon. So once there is a new bond formation between this carbon and this carbon, this bond pair breaks, this bond breaks. So that is how a compound is obtained. So what is the name of this compound? Name of this compound is called dioxide derivative. Dioxide means with respect to these 2 oxygen. And this particular one, so you know that this is a hydroxy group, and this dioxide in presence of traces of HCl. So traces of HCl means you can just pass the dry hydrochloric acid dry gas to the dioxide. That traces is enough. Otherwise, you can add 1 drop. So uh, instead of adding 1 drop, it's better to pass dry gas to the dioxide. So that will act as a traces amount. So for a minute, uh, then what will happen? So there will be a rearranges. How the rearranges? You know that this is a hydroxy group. So that means there is a breakage here. So breakage means a ketone. Uh, uh, what I can say that this I okay I will so look here, this particular bond, instead of forming a bond with this oxygen, it will form a bond with this oxygen, this hydroxy group. So that means migration. So the converting into a another form. So this is also a ketal. But in this ketal, this particular hydroxy group is not involved, but this hydroxy group is involved. So that is the difference. That means it is possible to convert a dioxide of one form to another form. So in presence of traces of HCl. So once this particular compound is obtained, this particular alcohol is treated with tosyl chloride. So what is tosyl chloride? Para-toluene sulfonyl chloride is called tosyl chloride. So tosyl chloride in presence of pyridine. So what is happening? A hydroxy group is converted into tosylate. So once the hydroxy group is converted into tosylate, it was treated with sodium iodide. So what is the role of sodium iodide? So I think you know that iodide, I minus, it replaces the tosylate. So that is how iodine is obtained. At this moment, a alpha hydrogen containing ketone, alpha hydrogen containing ketone is treated. So that means more particularly in presence of LDA. So you know that what is LDA? LDA is a strong base, but it does not act as a nucleophile. The role of LDA, just to capture this proton. So then there is a anion formation. That anion attack this carbon, and iodine is going out as a lithium iodide. So that is how a product is obtained. So then this particular product, when it is treated with one normal HCl, so one normal HCl will break this ketol. So ketol is converted into 2 hydroxy group. So you can also write the mechanism for the conversion of ketol to alcohol, vicinal alcohol. So what will happen? The lone pair present on this oxygen captures this proton. Once there is a bond formation between the oxygen and hydrogen, then this bond pair breaks. So that means this, when this bond pair breaks, there will be a what is called as a positive charge on this carbon. The water present in the HCl, it will attack here, and later this oxygen also capture a proton and breaks this. So that is how the ketol is converted into vicinal diol. So once there is a vicinal diol is obtained, so just on heating, there will be a removal of water. How the water is removed? The bond pair. So bond pair means bond between the oxygen and hydrogen, or maybe a lone pair. It will attack carbonyl carbon, and this bond pair form a bond with this oxygen and this carbon, and this OH is going out. So that means 1H from here, OH from this, it will go out, and it is cyclizes forming a multistriatin. So this is about the two methods of preparation of multistriatin. So just I will repeat the difference between the what is called as a brevicomin and multistriatin. The multistriatin and brevicomin differ only in one methyl group, and both are isolated from the same family but the different species. So that's what you need to remember. And with this, I will take up one more that's called Bambicol. So Bambicol is a pheromone of silkworm moth. I think you are aware about this is the silkworm moth, and more particularly the family of Bambax muri. Okay, it's a name of this particular species, and from this it is isolated a compound called Bambicol. So Bambicol will have this particular structure. More particularly, it will have a two double bond. This is one double bond, this is one double bond, and there is a hydroxy group. So I will look into the first method of synthesis of Bambicol. So in this two things is what is the name of this compound? Propyl bromide. Propyl bromide. Propyl bromide, when it is treated with sodium alkynyl. So al means a triple bond one. How you can get alkyne when it is treated with sodium metal? It will give you sodium alkynyl. So there will be a new bond formation. How the bond formation? The bond formation between this carbon and this carbon. So Br and Na will go out. So that is how a compound is obtained. Once there is a product formation like this, again you know that this particular proton is acidic in nature. If this proton is acidic in nature, what it will do, in presence of base, this proton can be captured. That means there will be a anion formation on this carbon. So that means this carbon will have a tendency to form a new bond with the electron deficient aldehyde, more particularly formaldehyde. That means formaldehyde is converted into CH2OH. So this is how a compound is obtained. At this moment, So this alcohol is treated with phosphorus tribromide. So what is the role of phosphorus tribromide? Phosphorus tribromide is a brominating agent. So that means it will convert a hydroxy group into bromide. Once it convert a hydroxy group into bromide, that was treated with a triphenyl phosphine. That means it is converting it a halide. Now this compound is called halide. So how this halide will be there? There will be a double bond formation between this carbon and this phosphorus. Once there is a double bond formation here, phosphorus attains a positive charge. That positive charge is neutralized by Br minus. Then this halide means halide. So it will react with this carbonyl carbon. That means there will be a new double bond formation between this carbon and this carbon. How it will form? Uh, just by capturing this oxygen. So that means here the living group is triphenyl phosphine oxide. So triphenyl phosphine and oxygen will go out as a byproduct. Of course, sodium bromide also will uh, go out as a byproduct. Ethanol also go out as a byproduct. For the sodium and ethanol, this is the base. This base is catalyzed this particular reaction, and this reaction is called Wittig reaction. So Wittig reaction means conversion of a carbonyl compound into alkene. So you know that this is the alkene. So this alkene is newly formed. This alkene is already present here. So this is how a reaction of these two, aldehyde and halide, can give a intermediate, a triple bond containing intermediate. And this compound is treated with Lindblad catalyst. What is Lindblad catalyst? Palladium sulfate over barium sulfate or quinoline as a catalyst poison. Hydrogenation. So Lindblad catalyst means it selectively converts a triple bond into double bond. Okay, that is the speciality about what is called as Lindblad catalyst. Then what is the compound is obtained? The compound is Bambicol. So this is only the Bambicol. So it is very easy to remember this particular Bambicol. How you can remember? Only the 3 methyl group here and conjugated double bond, and afterwards you just count the number of carbon atom and hydroxy. So 1 2 3 4 5 6 7 8 9 carbon atoms is there and hydroxy group is there. That's all. So you can remember that 3 methyl group on the left hand side, 2 double bonds in conjugation, 9 carbon atom and 1 hydroxy. That will be the structure of Bambicol. This is the first method of preparation of Bambicol. So what is the first method? So propyl bromide, it is treated with acetylene, sodium acetylene. It gives a triple bond containing compound. This was subjected to treated with formaldehyde in presence of base, so giving rise to alcohol. This alcohol is converted into bromide by treating with the phosphorus tribromide, followed by triphenyl phosphine. It gives halide. This halide is treated with a long chain aldehyde. So it will give you a triple bond containing compound. So this was treated with the Lindblad catalyst to convert a triple bond into double bond. And what is left over? The leftover thing is carboxylic acid. The carboxylic acid on reduction with lithium aluminum hydride, it gives alcohol. This is about what is called as the first method of synthesis of Bambicol. And let's look into the second method of synthesis of Bambicol. So up to this, means reaction of acetylene with the propyl bromide is same, obtained a triple bond containing compound on treatment with the formaldehyde is also same, but instead of going for halide, so here itself, uh, in the alcohol stage itself, it was a triple bond is converted into double bond by using Lindblad catalyst. So after the triple bond is reduced to double bond, so then this hydroxy group is converted into bromide by treating with the phosphorus tribromide. So that means hydroxy is converted into bromide. And now at this moment, so it was treated with the triphenyl phosphine. So this triphenyl phosphine, what it will do, it will convert this bromide into halide. Once there is a halide is formed, this halide react with aldehyde in presence of a base called phenyl lithium. Here the role of phenyl lithium is only the base. Then what is the living group? The living group will be phosphorus triphenyl phosphine oxide. The pH3P takes this oxygen and goes out. So that is how a compound is obtained. More particularly, ester is obtained, and this ester is converted into alcohol by reduction with lithium aluminum hydride. So this is about what is called as second method of preparation of Bambika. So now I will move to the next method, what is called as stereoselective synthesis of Bambikal. Stereoselective synthesis, I think you are aware that this is again one elide. Okay. How you can get this elide? Maybe you know that formaldehyde. So formaldehyde should convert into bromoformaldehyde. That bromoformaldehyde, when it is treated with the triphenyl phosphine, you will get this halide. This halide, when it is treated with a long chain aldehyde in presence of base, it will give you a compound, a alkene like this. This alkene again, it was treated with the butyl halide. This is the butyl halide. So then again a Wittig reaction, so giving rise to a carboxylate. This carboxylate on reduction with the lithium aluminum hydride, you will end up with the Bambikal. So that means just in 2 or 3 steps, a stereoselective synthesis of Bambikal is achieved. So why it is stereoselective? You can observe that this particular double bond. So what is the number? If you want to know this number, so this one is what is called trans, this one is cis. So that means this one is E, this one is Z. So E as well as Z is the stereo selective one. If this is cis, if this is trans, then it is not a stereo selective, because Bambikal, maybe you know that this carbon is 9 carbon and this carbon is the 10th carbon, 10E and 11Z. 10E, 11Z is the required configuration for the Bambikal to exhibit its property. This is about stereoselective synthesis of Bambikal. Here only the Wittig reaction is involved. The first step also Wittig reaction, second step also Wittig reaction, and the third step is reduction. So this is about what is called as uh, two insects, more particularly Bambikal, and one more is multistriatin. Okay, so multistriatin uh, as well as Bambikal. I have discussed about the synthesis, and more particularly in the Bambikal, I have discussed about stereoselective synthesis by employing Wittig reaction. This is about today's two insects. Maybe tomorrow also I will take up two insects pheromones. What is called tomorrow nanoxane. I am taking. And one more is farinol. I think you are aware about farnesol. So farnesol is a terpenoid, whereas farinol, Farenal, farinol is a insect pheromone. So tomorrow I will discuss about nanocosine and farinol, its synthesis and stereoselective synthesis. So this is about today's class. If you have any doubts, you can ask me. If there are no doubts, you can log out.